This video describes how AtlasIED's new line of AZM zone processors simplifies the problem of ambient noise compensation. Ambient noise compensation, or ANC, is an algorithm which automatically adjusts your system's levels based on the ambient noise levels in your zone. As a venue becomes busier, ANC will help ensure that your customers will still hear important announcements, or that background music will stay at appropriate levels. Central to our ANC system is the ambient noise sensor. Our AZM processors use the XANS noise level sensor, a calibrated SPL meter with a wide range of 30 to 110 dBA. Each processor supports up to 8 of these sensors, which are easily connected and assignable to a zone for ANC processing. Multiple sensors are also supported per zone. This can help avoid overreaction to local pockets of noise when ideal sensor placement isn't possible. Because ANC is a dynamic algorithm which responds to changes in the environment, it has traditionally required very careful installation and calibration in order to perform as expected. This is a painstaking and error-prone effort and is sensitive to changes in audio content and levels. Our new ANC system solves this issue by using an adaptive filter, a refined DSP algorithm capable of extracting signal and noise levels from the incoming sensor levels. Since this filter is built into our product, it's already calibrated and requires no tuning. This advanced filter can provide accurate ambient noise level estimates even while system audio is playing. This completely removes our dependency on changes to system audio levels and makes ANC much more robust to issues arising from poor sensor placement. Even without sensor calibration, ANC needs to know how to respond to changing noise levels. We'll refer to this process as gain calibration. At first, the solution seems simple: increase gain proportional to the ambient noise levels. But the problem is more subtle than it seems. At some noise levels, ANC should increase gain proportionally to the noise. But at some point, the customers start to raise their voices to compete with the rising levels, and ANC should stop increasing the gains. On the other extreme, we don't want ANC to drastically reduce the gains when only a few quiet customers remain in the zone. Accurately determining which noise levels ANC should respond to would involve an in-depth analysis of every install, since the environment varies from case to case. This makes the task formidable and time-consuming. If the integrator instead tried to guess the correct curve, he could easily end up with this or this. These curves will not do what the customer expects. Instead of trying to guess the correct curve, one common approach is to compromise by reducing the slope of ANC's gain curve and applying the curve to the entire noise range. It kind of works everywhere, but also doesn't really do what's expected anywhere. This difference between the customer's expectations and ANC's response can result in customer dissatisfaction and the impression that ANC just doesn't work. It seems like there should be a better way to do this. What if ANC could just magically calibrate its own gains based on your customer's volume adjustments? We found that this was possible, and it's the basis of our patent-pending auto mode system. Enable auto mode within ANC and let your customer do the rest. After just a few gain adjustments, ANC is calibrated to do exactly what the customer wanted, and it will do it every time after that. With our new AZM zone processors, we've removed the traditional barriers which made ANC seem ineffective to customers and hard to manage for integrators. Just enable auto mode and let ANC give the customer exactly what they want. You now have an ANC system whose calibration is as simple as plug in the sensor, enable ANC, and walk away.